Hey folks, welcome to another set of Intro Chem video notes. In today's lesson, we're going to discuss the different types of chemical reactions and how to predict the products of a reaction if we know the reactants. Here's the standard we're covering. Let's get started. The first thing you need to know about chemical equations is that they're like a recipe or a set of instructions for making something. They tell us how many things we need to put together to produce something new. The chemicals we put together are called reactants and are found on the left side of the chemical equation because they're what we start with. The right side of the equation holds the products because they're what we end with. They're what gets produced. Then when you see those big numbers like in front of the H2O here, those are called coefficients. Those tell us how many of those atoms or molecules there are in our reaction. All right, let's get into the 5 basic types of chemical reactions. The first one is called synthesis, or combination. This is when we take 2 compounds or elements and combine them together into one compound. You can recognize these because you'll have 2 things in the reactants of your equation and only 1 thing in the products. Predicting the compound that gets formed from these can be quite tricky, so we'll stick to fairly simple ones in here, often ones that start with just 2 elements, a metal and a nonmetal, in the reactants. Then you can figure out the ionic compound it would make in the products. A decomposition reaction is just the opposite. This is where we start with only 1 compound in the reactants, and then we split it up into 2 or more smaller compounds, or even just elements in the product side. They're easy to recognize because they're the ones that start with just 1 thing on the reactant side. You can remember this one because the name decomposition means breaking down into smaller parts. The displacement, or sometimes called replacement reactions, are the 2 trickier ones to memorize. This is where we start with 2 things on the reactants, some atoms get switched around, and we get 2 different things on the product side. In a single displacement reaction, the 2 things we start with are an element and a compound. That element swaps places with one of the elements in the compound, and then we end up with a new element and a new compound. In the example here, we have zinc as our element, and it swaps places with hydrogen, giving us elemental hydrogen and zinc sulfide. A double displacement is very similar, but instead of having 1 element and a single compound on each side, we have 2 compounds on each side. Double displacement. In this example, you can see the O and the S just swap places in their respective compounds, and we end up with 2 new compounds formed from it. Lastly, and the one that's fairly easy to recognize but also easy to forget to look for, is combustion. In a combustion reaction, some compound, usually a hydrocarbon in the examples that you'll encounter, and oxygen react together to form carbon dioxide and water. The only real requirement to be a combustion reaction is that oxygen is a reactant. The products are usually carbon dioxide and water, but not always. When the other reactant besides oxygen is a hydrocarbon, then the products will for sure be CO2 and H2O. You can remember this one because combustion is like fire, and 2 of the 3 requirements for fire is that we have oxygen present and some other fuel source, the other reactant. Before we get into the nitty-gritty of predicting products, let's look at a few hints that will help you along the way. First, you have to remember our Brinkelhoff elements, the 7 elements that in their elemental state exist as diatomic molecules. That means when we know we want a product to be an element by itself, and that element is bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or fluorine, we're never going to just write down its symbol. We're going to write it as Br2, I2, N2, etc. There's always 2 atoms for 1 molecule for those elements in their elemental state. To predict the products for synthesis reactions, we just smush the elements together and make sure that their charges cancel, just like we did when we created formulas for ionic compounds. For decomposition, you just take the 2 elements in your reactant compound and split them up into their elemental forms. For single or double displacement, the easiest way is to assign charges to each element, then swap the cations, or positive elements, places. Don't carry over any subscripts unless they're part of a polyatomic ions formula. Then make sure your new combination of metals and nonmetals cancel out their charges. Lastly, for the examples I'll give you for combustion, the products will always be CO2 and H2O. The very last step to predicting products will be balancing equations, but we'll get to that in the next lesson. Here's a handy flowchart, which you also have to glue into your notebook to help you figure out what the products of a reaction will be. I think that's all for today, folks. If you have any questions, please ask.